These are notes for section 10.3. Okay, 10.3, page 582, 1 to 53 odd and 59 to 81 odd. So a couple pages. Some problems there. Some more. More. And then on the next page, some batch over there. Up to 81. Okay, answers in the back of the book. Let's see, 10.3. Where's 10.3? There we are. Go up a little bit higher. Scroll a little bit to the right. And then some more further down. Move over to the right. And let's see the bottom there, 10.4, just to be safe, give you all of that. And all of that. Okay, so you should be able to see all the answers. Okay, so today we're doing logarithms. Okay, logarithms, or logs for short. Okay, so you will see y equals log base b of x. So log, there's a little number underneath the g, that's the base of x, that's the way we read it. It means the same thing as b raised to the y power equals x. So the way you unscramble this, write it without the log, is start with the base, b, you go across the equal sign for the exponent, y, then you come back in for the result. So b to the y equals x. It can be written this way also. This says the same thing. Log base b of x equals y. Base is b, exponent is y, come back in for the x. Okay, here's some examples of logs. Log base 2 of 16 equals 4. Write it without the log. 2 raised to the 4th power is equal to 16. Okay, or log base 10 of 1,000 equals 3. 10 cubed equals 1,000. Okay. Log base 7 of the square root of 7 equals 1/2. Write it without the log. The base is 7. Go across the equal sign for the exponent. Come back in for the result. 7 to the 1/2 equals square root of 7. Okay, so let's try some problems here. Problem 13. Log base 10 of 100 equals 2 means 10 squared is equal to 100. Okay. Log base 8 of 1 equals 0 means 8 raised to the 0 power equals 1. Start with the base, across the equal sign for the exponent, come back in for the result. 21, log base 6 of 36 equals 2. Write it without the log. Base is 6, exponent is 2. Come back in for the result, 36. Okay. 23, log base 5 of 1 over 25 equals -2. 5 raised to the -2 equals 1 over 25. Okay, how do you go the other way? Write it as a log. Okay, so jumping back to number 1 now, write this as a log. So first you write the word log. You start with the base, so the base is 2. Okay, now you just have to figure out where's the 4 and where's the 16. Well, the 4 is always by itself on the other side of the equal sign. So you go across the equal sign for the 4, come back in for the result of 16. Okay, 5. 0.01 is 10 to the -2. Okay, so which is considered the base? 10. So write log base 10. Okay. Now the exponent is by itself, so the -2 is by itself. Come back in for the result. So it should look like this: log base 10 of 0.01 equals a -2. Okay. As a matter of fact, log sometimes is called common log. You might see some log equations or expressions that don't have any base. If you don't see any base at all, it's understood to be base 10. Okay, so on your calculator, hit the button that says log. There's supposed to be a base next to the G. There is no base, so it's understood to be 10. Okay, and you can't really forget it because if you just peek ahead, it tells you that the base is 10. Likewise for standard scientific calculator, log LOG, above it says 10 to the x power. So it's not really any mystery. I wonder what the log base is. Well, you just peek up here and its base is 10. Okay, 1/2 to the -3 equals 8. Write it as a log. So write the word log. The base is a half. Exponent by itself, -3. Result is 8. Okay, 25, we're solving some equations now. Log base 3 of x equals 2. So unscramble it. Okay, to unscramble it, you get rid of the log. Base is 3. Exponent is 2. Come in for the result of x. So 3 squared equals x. X equals 9. 29, log base 2 of 16 equals x. Okay, 2 raised to the x power equals 16. So 2 raised to what power is 16? Well, it's 4. So the answer is x equals 4. Okay, log base x of 4 equals 2. Unscramble it. X squared equals 4. Square root property. Ordinarily, you would say plus or minus, but the basis for exponential and logarithm functions is always positive, so don't allow for -2. Only x equals 2. 37, log base 5 of 25 equals x. Unscramble it. 5 raised to the x power equals 25. X is 2 because 5 squared is 25. 41 is a little bit harder. Log base 8 of 4 equals x. Unscramble it. 8 to the x power equals 4. Okay, now we don't recognize this, but the trick is to write both of these in terms of base 2. So 8 is 2 cubed. So this is still 8 to the x. 4 is 2 squared. Now I have a root in exponents that says I can multiply these two. 2 to the 3x equals 2 squared. So once you have it like this, 2 to something, 2 to something, these two somethings have to be equal. So 3x equals 2, x equals 2/3. And a little double check. 8 to the 2/3 means cube root of 8. Remember, it's power root. So third root, cube root of 8, and then you square it. Cube root of 8 is 2, 2 squared is 4. So that double checks with the original problem that this should be a 2/3. Okay, log base x of 5 equals 3. Unscramble it. X cubed equals 5. So I take the cube root. I want the cube root of 5. So the answer is the cube root of 5. You can punch it in your calculator if you want to. You don't really have to, but that's the idea. Okay, log base 9 of 1/3 equals x. Unscramble it. 9 raised to the x equals 1/3. Okay, so try to get both of these to be the same base. 3 looks like a good base. 9 is 3 squared. So this is still 9 to the x. 1/3 is 3 to the -1. I can multiply these two. So 3 to the 2x equals 3 to the -1. And that's what I want. I have 3 to something, 3 to something. So I can equate these two exponents. 2x equals -1. X equals -1/2. And by means of double checking, does it make sense? 9 to the -1/2. Does it satisfy that? -1/2 exponent means 1 over 9 to the +1/2, which means 1 over square root of 9. It is 1/3, which matches what we had up here. So that seems to work okay. Okay, a couple of graphing problems. Graph y equals log base 3 of x. The best way to graph this is to unscramble it. 3 to the y equals x. Okay, when it's written like this, it's best to make a table of values for y. Let y go from -2 to 2 and figure out the x. Okay, so if I plug in 0 for y, x is 1. Plug in 1 right here, x is 3. Plug in 2, x is 9. Plug in -1, 3 to -1 is 1/3. Plug in -2, 3 to -2 is 1 over 3 squared, 1/9. So 1/9 -2 is something like that. 1/3 -1, 1, 0, 3, 1, 9, 2. So the log function looks something like this. Okay, y equals log base 1/3 of x. Unscramble it. 1/3 to the y equals x. So same thing, I make a table of values from y going from -2 to 2. Plug in 0, 1/3 to the 0 is 1. Plug in 1, 1/3 to the 1 is 1/3. Plug in 2, 1/3 squared is 1/9. Plug in -1, 1/3 to the -1 means you flip the fraction 3 to the +1, which is 3. Plug in -2, 1/3 to the -2, flip it, 3 squared, 9. And so you plot these points. So 9, -2 is over here, 3, -1, 1, 0, 1/3, 1, 1/9, 2. So it looks something like this. Okay, here's a problem where it asks for the base, y equals b to the x power, and it goes to 2, 9. So I put a 2 right here, a 9 right here, and b has to be 3, not negative 3. So y equals 3 to the x power. Okay, y equals log base b of x. Unscramble it. B to the y is equal to x. Okay, now you're given the point 9, negative 2. So 9 goes in here, negative 2 goes in here. So b to the negative 2 equals 9. That means 1 over b squared equals 9. Multiply both sides by b squared. 1 equals 9b squared. Divide both sides by 9 and take the square root. B is equal to 1/3. Okay, y equals log base 1/3 of x is the final answer. That's the base that you want over here. Okay, 61, log base 25 of 125. Call it x, unscramble it. 25 to the x equals 125. Get these to be the same base. What's a good base? 5. This is 5 squared to the x. This is 5 cubed. Multiply these two. 5 to the 2x equals 5 cubed. That means 2x equals 3. X equals 3 halves. Double check. 25 to the 3 halves means square root of 25, 5. And then you cube it. 5 cubed is 125. Log base 3 of 3. Call it x. Unscramble it. 3 to the x equals 3. X is equal to 1. It's an x there. 69, log base 17 of 1 equals x. Unscramble it. 17 to the x equals 1. Well, we know anything to the 0 is 1, so x is equal to 0. Log base 100 of 1,000 equals x. Unscramble it. 100 to the x equals 1,000. Write both of these to the same base. How about base 10? This is 10 squared. This is 10 cubed. And now you get to multiply these two. 10 to the 2x equals 10 cubed. Same base. Therefore, the exponents must match. 2x equals 3. X equals 3 halves. Then we have some more complicated ones. They give you a log of a log. Log base a half of log base 3 of 81. So first take a timeout. Forget about this. Just figure this out. Log base 3 of 81 equals x. Let me call that x. X is log base 3 of 81. Unscramble it. 3 to the x equals 81. 3 raised to what exponent is 81? X is 4. Okay, so now I know this thing is 4. So I'm trying to find log base 1/2 of 4. So now I'll call it y. I'm not supposed to call it x again. I've already used up my x for the question. So I'll call it y. Unscramble it. 1/2 to the y equals 4. Write them with the same base. 2 is good. This is 2 to the negative 1. This is 2 squared. I get to multiply these. 2 to the negative y equals 2 squared. Now that I have the same base, I just equate the exponent. So negative y equals 2, which means y equals negative 2. Okay, finally, 81 has log, log, log. Okay, looks scary, but just do them one at a time. Just focus only on this. I'll call that x. Okay, ignore the 4. That's going to be the answer, but I'll show you where we get that from. Okay, so x is log base 2 of 16. Unscramble it. 2 to the x equals 16. So 2 raised to what power is 16? That's 4. So now this thing is 4. So I'm going to rewrite it. Instead of all this mess, I'll write it as 4. So here we are, log base 4 of log base 2 of 4. Okay, so now I have to figure this out. Ignore the 2. That's what it's going to come out to be. So I'll call that y. Log base 2 of 4 equals y, or y equals log base 2 of 4. Unscramble it. 2 to the y equals 4. What exponent makes this true? 2. So y is 2. So this thing is now 2. So now I'm left with doing log base 4 of 2. Log base 4 of 2. I can't use x. I can't use y. How about I use z? Unscramble it. 4 to the z equals 2. Write them with the same base. 2 squared, that's 4, to the z equals 2 to the first power. 2 to the 2z equals 2 to the 1. Same base, so now I equate the exponents. 2z equals 1, z is equal to half. Okay. All right, so that was section 10.3.